If you have come here to learn about quantum weirdness, you have come to the right place. Okay, so today we're going to be talking about quantum weirdness. Now, basically important things to note that when I say half, it's random, and you don't actually differentiate between the particles, and the amount of particles used does not matter. Also, this ice is the particle's path. Now, quantum weirdness, how about we start with the particles have different characteristics. These can be electrons, photons, or any other particle. In this case, the shovels and axes will represent any particle. Half of these are shovels and axes, and half are wood and stone. For this experiment, you can imagine that you can't tell the difference between the tools. Obviously, you can see the difference, they're there, but imagine like it's blurry, you can't actually tell. Now, the characteristics of the actual particles, for example, would be speed and location. Now, this divider stops axes so shovels can go through one way and axes get stuck here. As you can see, half are stone, half are wood. Makes sense. All the axes are there. Now, when you get to this middle part, half go in each different way. Doesn't matter which way I go, they're both the same. I made it symmetrical. Now, when you get to this point, it gets all of the stone stuck in here and all the wood can go through. So the stone should be in there. But you would expect all these to be shovels. I mean, all the axes were already taken out, right? However, there are shovels and axes in there, as well as a reduced number since we keep cutting stuff in half and half. Now, this right here diverts the particles back to the center. Now, since we think we got rid of all the axes, we got rid of all the stone, it should be wooden shovels they got here. However, half are shovels and the half are axes, and they're all wood. Now, this has to do with the uncertainty principle. Somehow the particles, they don't keep, you can't tell two different things, and no matter how smart you are, you can't trick it into telling you things. And also interesting, if you only divide one part of it, you still get very interesting results, and we'll discuss that later in the video. Now, I got my information from The Whole Shebang by Ferris, a very good book, and uncertainty principle says it's not possible to tell multiple characteristics of a particle. When you try to find the second characteristic, the first characteristic goes out of focus as you focus on the second one. For example, you can't know how fast a particle is going and where it is at the same time. Quantum physics uses this information as a probability, and it determines the odds of the location and the odds of the speed. Now, you can't really say where a particle is and how fast a particle is moving. Now, in this video, I showed the tools so you could see, but in reality, you can't tell which particles have which characteristics. All you can tell is that half have one characteristic and that half have the other characteristic. Now, it gets fuzzy from here and sort of complicated. Now, in the second part of this video, I'm hoping to show you what happens when on one side we divert and it stops, and on the other side we just let it go through from there. Now, something very interesting happens. It's not quite what you expect. You see, when you get to that first division, you don't divide anymore. You just let it go all the way through with half of them. But it doesn't quite work out how you would expect. Welcome back. Now, it's all the same. It's the same map, sort of, except for one important difference. You see, all this is the same signs, same chest right there. Now, as we go through this ice path, you can see same divider, gets rid of the axes, lets the shovels go right through. It's important that it's all the same at this point. However, this is where it gets different. Actually, not yet. You divide it in half. Now, right here, it's still all the same on this side, and this divider does stop the stone, and it stops the stone right here. You get all the same results that we got in the other one. However, here it stops, and you aren't actually connected to the main area. So these particles are stopped. The wooden particles here are just stopped. Now, on the other side, once we get there, you'll see that there is no actual divider after this. So these particles, in theory, should only be divided, they should only be shovels of wooden and stone characteristic, because we divided away the axes and left the shovels alone. But half are axes and half are shovels, and they're all wood. Now this is extremely odd because we didn't affect these. We did a change on the second path, but not on this one. Now, this is very difficult to explain, and it's like the particles don't behave locally. They have a sort of non-locality to them that is reminiscent of, well, the Big Bang. You see, when the Big Bang first occurred, everything, well, before and during, everything was in the exact same spot, which is why some people theorize that all particles are all the same particle, which is an interesting idea. I don't know. I'm not a professional on the subject, but imagine if all electrons were the exact same electron, just in many areas, such as like when the Big Bang actually happened. The electrons were all in the exact same spot. All matter was in the same spot, and that caused some interesting situations. And that's why when we talk about quantum physics, it's different from regular physics. The quantum physics, of course, being in the micro, and physics we know about and can understand clearly being in the macro. Now at this point, I'm including actual pictures of quantum weirdness, as they are put in the book by Timothy Ferris, The Whole Shebang. If you want to read up on that subject, I suggest you get that book. If you want to read up on other subjects, such as, I don't know, the beginning of the universe, relativity, I would read A Brief History of Time by Stephen Hawking, or... one second, please. The Elegant Universe by Brian Greene would also be an excellent book to read. Now, if you have any other ideas for videos that you would like me to do, something that you would like me to explain, I would be happy to help. Simply leave a comment in the comment section. Thank you.